How's it going, everyone? Welcome, Eulier Gonzalez. That's right. So, today we're going to explore about the hard part of servers and Node.js, especially to understand now how things, the inner mechanism when we now create a server using the HTTP protocol, HTTP model from Node.js. So what's going on behind the scenes? As a way to explain that to somebody else, and even college or non-tech savvy people, to make all of these abstract ideas meaningful to them. Why is that? Because especially if you want to sell this particular services, it's like, hey, I am someone that can you help to debug, fix, improve, or set up a server. Now I can make it meaningful to you, regardless your background. And this is one of the critical aspects that a lot of software engineers lack of, the soft skill. And I get it why, for example, in top tech companies like Meta, Google, TikTok, yada yada yada, Netflix, is say, hey, we need to have at least those top engineers to give some sort of speech to make it meaningful to others, to, in this case, the audience on the industry. Hey, why are we doing the things that we're doing? What are the foundations? Talk in this abstract sense, and now digest in a way that others can be consumed that easily. And it's up to the audience to say, hey, yeah, I would like to go on more about this, or no, I will stick with this. I want to see what is the practical approach, and then I can do something about it. Now, this is exactly the reason why I'm looking at this particular course taught by Will Sentence. He's the CEO of the CodeSmith, this software engineering and machine learning residency, which is a fancy name to say this is a boot camp, headquarters on New York, San Francisco, and London. So I really love the engagement that he brings here on each one of their videos. I'm just going to take notes out of this course because I don't want to receive any red flags. I already did that. So the front-end master legal department contact me and say, hey, you shouldn't do that. At least you shouldn't record our videos while you are taking notes out of this. But so far I haven't received any flag from their audio. But in any case, and I really love the way of how now he expressed, because this is something critical, especially if you're going to learn anything, all right? And if you're going to explain something, this is the way of how you can make things happen. So in other words, for example, if you're in your work, hey, if I explain all of this abstract concept in a meaningful way that you can actually at the beginning try to understand and grasp on, and then over the couple weeks you can now be fully autonomous and improve, fix, and debug the code base. That's the end goal of any senior citizens, or I say any senior developers here. I will argue that also in other areas that's the role of any other seniors in other areas, but in the context of computer science and software engineering and machine learning is this, all of this complex and cloudy aspect, right? So cut the fluff and now give me is, or provide is in a straightforward way. So that's why I really engage with the front-end master more than in any other courses out there, where and it is also the format, the live stream format that they have is something that you can actually take all of these small cues in their body language, their facial expression, and also the tone they use. So you can say, oh, there is more than the just words and the communication of that. There is also pain involved. So that's also why a lot of people, including myself, love to read books. But right now it's more for exploring ideas, and unlike the live streams where you can see the person in a book, you can use your mind, and it is less filtered, because on a book it's actually is trying to bring something to those pages. So that's why I love this particular formats of these live streams teaching videos, because they also walk through the entire process, and it is up to you to pay attention to all of these small clues, similar like when you had 4 years old, right? You dedicate entirely your attention to one particular topic. You fully immerse into that to see how that things work, and then you do something else. So in today's video, let's go into now explore about that. So this is the course section. Oh, I didn't put it here. Oh, anyway. So to understand that, how do we get here, right? Especially on the using Node APIs, what's happened when we use any of this nodes models, and explore exactly what is the inner mechanism behind the scenes. So again, the TLDR is that quick recap of how do we get here, especially on Node. And to understand now Node, we need to explore is the entire web and how that happened, right? That's why I actually have this A.K.A. draw, this particular draw here, okay? To understand at least what's going on anytime you, for example, whether it's Seth, Maria, Brian, Becky, Shirley, or Matt, Mauricio, you name it, right? Is if from any of their computers, anytime they want to search for tweets, you now there is a lot of things going on. So what happened is that when you get in a browser, you type to get your tweets. That is a message that is sent to the OC model, which is the way of how now this computer with different architectures can interconnect each other, all right, known as the OC model. Yeah. So when your browser now wants to have access to the networking services to actually transmit this data, it passes through the OC model, where you have 7 layers. The first is the application that is trying to communicate with the networking service. Then you have the presentation to ensure that it is in a usable format, and this is when encryption happens. And you have the season. Now the OS is coordinating and controlling the port and the season where this data is going to be sent. Then you have now the transport layer, which say, hey, what will be the set of rules that we're going to use to now transmit this data? And this is when this huge message that you're going to send is split into small different small envelope, you can call it. And then here you have now the TCP or the UDP. So the TCP is something that is connection based. The reason why this particular protocol exists, known as the transfer communication protocol, is because before this, we're talking about in the 60s, there's something called the network control protocol. The approach was to say, hey, we want to have control of what's happening here in this network, in all of these different computers, it turns out that this works fairly good for small network, but what happens when you want to add more computers or more network of computers, right? And when you want to interconnect each one of them, so that becomes a nightmare to manage. So TCP say, hey, let's go to look at from a different approach, where instead of trying to control the entire network, let's go to look at the communication in itself. So we want to have now a reliable, error-free or less error-prone way to communicate two devices, no matter the physical path, no matter the network where they are. So that's why we have now the TCP. So it focuses on the communication aspect, not to control the network. And it turns out to be something that is quite good. But what happens if each one of those computers in this network are jumping from one to another, which is what happens when you have a cell phone and you go out to the route and you hop into different network antennas? What happens is that you are actually doing that behavior. So TCP is not that good to handle and to manage that. So that's why we have protocols like UDP, where you don't need to communicate or where you don't need to establish a connection base with another device. You just only want to send data to that device, right? You want to only send data to the device. So no matter if this end device is jumping from one network to another, you just only care that you're sending that you're sending. So for example, quick protocols, and I even have something here. So from this, from system design, did you get it? In this front end system design, you get stuff like the network connectivity, right? So on the network connectivity here, we discussed about that particular approach. So let's get into this. Wow. Yeah, this is explaining now what's happening here on the navigation here. But it's this one. This is what I want you to show you. I want you to bring your attention to this. You know, so WebRTC is based on the UDP as well as the Quick protocol, which is developed by Google. And HTTP 3 is based on this particular protocol Quick. But that's quite interesting, and there's some other applications out there, for example, when you're building games and stuff like that, that has been proved when you need this real-time communication, no matter the device, that this protocol, this WebRTC, that is using UDP, you don't need to connect, you just only send the message. So if this is the end device is moving from one another like this, so if the end device like this, so let's say you are sending a message, this is the origin, all right, and let's say you are sending a message to this computer. So no matter if this computer, for example, moves to another one's network or to this or to that, all right, you only care to send message to wherever is that device, regardless the network. So but I think this is quite important to understand why what is the problem that this protocol wants to solve, period. And then you have now the network here, the data link as well, and the physical. So the network say, hey, what is the physical path that this what is the physical path that this data will take? All right, and in the data links, focus is on the format on which this data is going to be sent from closed device, and not end to end, is from these two closed device. And then the physical that transforms all of this into a streams of data, octets, but to be specific, that actually is sent to the ESP. The ESP has some DNS servers, which is like a dictionary, when the whole is their IP address that match that URL that you send from the browser, that is sent back to the client. The browser, aka the client, receive that, might store that IP, and then is when the TCP connections happens, which is this handshake, the TCP handshake, which is syn, synac, sync, syn, synac, ack, which means is that it's sending now a sync to the server, and the server get this data. I'm just briefly talking about what's going on. All right, for the sake of this example. So the first is the client send now a sync to the server. The server received that sync, and then now send a synac to the client. The client received that, and therefore, all right, it sends now an acknowledge to the server. So now the actual HTTP connection can begin. Before this, before now, the cloud or the internet was so insecure, or which is the reason why we have encryptions. So now it happens the TLS connection, and then it happened the TCP connection, and then the TLS connection, the transport layer secure, or the secure layer, secure socket layer, right? Is a way of how now they're going to send the encryption data. Let me see if I have this exactly. Right? So this is the TCP handshake, what happened here, right? In a TCP base. So it sends now the synac received by the server, and the client send a acknowledge. And if you want to now set an HTTPS connection, it's saying now the client hello, all right? The server reply with the server hello and the certificates for that. The certificates and the SKAX. Okay, server key exchange. Okay, the server key exchange. The client received the server key exchange, and they now going to send the client key exchange and the certificates, and then now the server receives that certificate, send back, and that is when now the data can happen. But look at all of the different stuff that needs to happen only to start a communication to this. All right, this particular protocols that need to happen, similar to but unlike the UDP or the quick, is only say, hey, I'm gonna send an initial hello. I'm gonna have it, and you're gonna have from that initial hello is from that initial server hello, the certificates and the end, and then I'm going to send now the end or the fin, I think the finalization, I don't know, and then the thing and the data. So it shrink. So instead of have synac act, and on the act is also sending the client hello, server hello with the certificate and the key exchange, the server key exchange, and then the client exchange and the certificates receive the certificates from the server, and then it's gonna send the data. So you have here now 1, 2, 3, 4, 5, 6, 7 steps to send data. Here you shrink that a lot with only 2. That's massive improvement. That is a massive improvement as it is. And there you got it. Okay, so the point here is that once we look at that, okay, and that message is received by the Twitter's headquarters, here on the server, and those servers might be reading on PHP, Java, Python, in JavaScript, and also C and C++. So because JavaScript is a powerful scripting language that runs this on the browser, but also now on the server. But the thing here is that JavaScript per se doesn't have access to the inner computer's features, unlike, for example, Ruby or Python or PHP and other languages. So how can we now make sure that this powerful scripting language that provide interactivity to the browser, along with the CSS to purify stuff and HTML to give a structure to the document that is going to be shown on the browser, how can we now have access to this internal inner computer? That's where now Node kicks in. So Nodes give us here is the ability to have access to those internal features from JavaScript, and it is great for doing specific couple tasks. You know, for example, creating a server, or reading a file, or reading or writing a file. Why is this? Because now LeafUB, which is the library that allows to handle this input and output operations that live inside of the Node.js, and LeafUB is a cross-platform library that allows to do that. Here we're going to explore is how can we create this HTTP server with Node, and what's going on behind the scenes. Is before doing that, we need to at least refresh is what JavaScript does, what is the nature of HTTP, and what so what Jesus, oh my god. So what JavaScript does, what Node or how Node.js works, and the nature of HTTP mechanism as a way to refresh that. So the TLDR is, hey, what JavaScript does is to allow us to save data and its functionality to be later used, to be used later on, and also by using the data or use that data by running functionality on it, okay, and have access to labels that are exposed in the language. So you know the words, for example, in the context of browsers, is the set timeouts, the navigation, the canvas, but now here on the server is to have access to the different models that Node exposes to the different computer inner features. So you have now net and HTTP, also crypto, read a file or file system, so you can work with that. There's other couple stuff there, other models, and how you're going to organize your application using models, whether it's CommonJS and now recently is ESM, okay. But the idea here is, at least for this video, to see how can we now is create this server and what's going on behind the scenes, and that is understand what JavaScript is doing. So the TLDR with this JavaScript is that, as you can see here, so JavaScript allows us to save let me put it here. That's right. So JavaScript now allow you to is save is this value as a primitive number. So say the value of 3 in this using this identifier that cannot be redeclared. That's the meaning of let. And the function say, hey, I want you to create is this set of instructions that is going to be saved on this label in memory. So here both of these are reserving space in memory for a primitive, for a variable of for a variable called num with the value 3, and the identifier called multiply by 2 with the value of a function, all right, like so. And then we're gonna call it, all right, and we're gonna call this functionality on a data here that we pass manually. And this is part of the thing that is going on behind the scenes with Node, which is something that we're gonna see that later. And by the time that you know the way you run a function is by using parentheses in JavaScript, okay, you pass the identifier, and if that identifier is a function, you execute that with parentheses, and then you pass manually the arguments. Similar for this, okay. So what it's doing here is to, well, evaluating this code, and we also recap about is the anatomy of the synchronous aspect of JavaScript, which is the global execution, the function execution, as well as whether it have is the threat and the lexical environment or the memory, all right. And then you also have is the call stack, which is going to evaluate at which line of code is JavaScript running into, and the heap. So this is the place where we're going to allocate memory here. This is the anatomy of the synchronous aspect in JavaScript. However, if you need to handle is the asynchronous aspect, something we're going to talk about that later, we have now is the event loop and the micro tasks, the macro tasks that help us to, when we need to use a specific label, so for example a set timeout or promise, we can now is pass this set of instruction functions to a micro task or macro task that by the time that this file is being executed, now it is time to look up for those instructions that we queue on this micro task queue or macro task queue. All right, but again, our focus here is to understand what JavaScript is doing. Okay. Now, how Node.js actually execute code? So because now expose certain labels, all right. So one of them is the net that give you give you access to the network features, these internal computer network features, and we have now a more specialized a model from Node called HTTP. Net allows you to create is whether it's stream-based TCP servers and IPC servers, whether it's to communicate with other computers or to communicate with internal process or the internal process communications. So whether if you are executing instance of your code, if you're executing programs locally, all right, or if you want to communicate with external computers, TCP to communicate with external computers, and the IPC to communicate is with this internal program that you're running. And I think this is quite interesting. So for example, Windows has this called stuff pipes, and in Unix you have sockets. So you have a Mac or a Linux, you are used to the concept of sockets. If you have now Windows, you are used to the concept of pipe. But in any case, so that's why we are actually using is the HTTP, because this model actually what it does behind the scene is to create this server, and by using now this command here, this function, what it's doing behind the scene is to say, hey, Node is creating an object for you, given to you, that has a lot of property and events that you can now listen to or subscribe to, okay? and by the time that that event happens, which is handled by Node using the leaf UV, is going to now automatically run a function that you pass to them. Bear with me. bear with me. Okay, so here this is gonna return us is an object. So far so good. Okay, so this object here, you say, hey, create server. So create server Node.js. You got it. Create server, right? So this will return us is this HTTP server. So HTTP server. Now look at. Let me see if HTTP server can we look at this. Say server. There you got it. Exactly. So this will so Node behind this thing is going to create this object for you. All right, and it's going to provide you is the set of events as well as methods and properties. So properties are those who are not any parentheses, and methods or functions are anything that has now parentheses. Okay, so parentheses. Okay, so you have these methods, these internal methods, but this is our property. But the thing is that this is good. So we are running now this method called listen to say, hey, please, I want you to now, behind the scenes Node, start an HTTP server ready for listen for connections. So this is identical to the server.listen from net server. So now if we look at here the net, this is the net exactly. So let me do something here. Here, as you can see, we are in the HTTP. Okay, if I go to the net server, this is now the net model. It's a net server. Okay, let's go to now the net server. It's going to create is this. All right, and it says that this method is identical to server.listen from net.server. Okay, so we're using this general network networking model called net. You have here is the these events that you can start to listen to, all right, as well as this, the address, the other methods, address, close, listen, and on ref. So this is just to create is a server. This server extends from the event emitters, so you can now see what's going on here. This class is used to create TCP or IPC servers. So if you take a look at the event emitter here, the event emitter class defined is exposed to the node models event. All event emitters emit all event emitters emit the event new listener when listener are added to remove listener, when existing listener are removed. It supports the following options: capture rejections, boolean. It enables automatic capturing of promise rejection, default false. Event name, listener, event emitter. The fact that event is triggered. Okay, but I just want to explore here the class event emitter. Let me go up here, right? This is from the model event. Okay, so the class event emitters has all of this, and as you can see, the point of exploring here is that behind the scenes is using is this notion of the event listener or the queue events here. So well, this is all of the property and method that you can also listen to. So new listener, remove listener, and that kind of stuff. Event capture rejections, blah blah blah, capture rejections and event nonce. Okay, but again, we go back to the net server. It create now this. So start an HTTP server, listen for connections. And you might wonder, what does it mean to start an HTTP server, listen for connection? Let's going to explore. Let's going to talk here with Claw. So start the HTTP server, listen for connection. How do you do in Python, C++, PHP, and Java? So this is the line of code that you need to do in order to create a server. Holy hell. Look at this. So here in Python, you need 5 lines, 6. You need six lines, 7 lines. You need 7 lines to create a server. You say, hey, let's go to import the HTTP server model. Let's go to import now the socket server. It's going to define this cons here. You can also define those cons here as it is. And also the handler, simple request HTTP handler. Handler here. And HTTP here. And this is also how you can now create a server on the C++. So you need to, this is now low level. You need to talk to the asynchronous library, IO_streams, and streams, the data structure. I'm assuming that this is another data structure using both data ICO for a simple HTTP server. So you need another model to create that. And from those models, you need to get that and say, hey, int main, you're gonna try this. So I want you to now is reserve space in memory for these 2 variables, starting to accept now the connections here in the TCP, so you can now receive is from this particular version and from this port. Server listen on this port, and then you have to create now a loop here to start listen for incoming requests, which is exactly what it's doing here. Is that, hey, anytime you have a socket and you get something, all right, let's go to now response with this. Okay, and this is all the lines of code that you need to create a server from the scratch, from PHP. Okay, that's quite interesting, because you can have access to this using PHP built-in server command line, run with PHP -h localhost 80. Socket create is this, socket bind, socket and host and port. Okay, let me bind this. Okay, this is global. Okay, this is global properties, global method that have PHP here. Socket create. So you need to create a socket. Okay, and pass some, I think, global scope parameters here. AF inet sock_stream sol TCP. And then you have to set up the socket here to bind that socket and then listen to that socket. Holy moly, bro. So also, then you need to create is a loop for that, which is, hey, I want you to know by the time that you receive any data from this socket, okay, socket accept, I want you to now read the data that I get it from here and then responds this. And once I going to define as a response, I want to now send that socket write and socket close. So this is, oh my God. This is quite interesting in terms of explore how can we create is a server from the scratch in one of these languages. Holy bro, holy moly. So here we have access to several methods using the HTTP provided by the net layer here. It's like, hey, this is not HTTP server, this is how you're gonna handle it, this is what you're gonna exchange, and the input and output section to capture any errors there, as well as the output stream, and then the init socket address. Holy bro. So you define here your simple server as it is, like this. Okay. And then you started to create the server on that particular port. Okay, init socket address. So you're gonna create a context, new my handler. You're gonna set the executor here and then start the server. You can print that out. So by the time that it detects any handler here, as you can see from the server instance, it says let's go to create another context about it. When you listen for incoming events here, you're gonna now execute this handler for us, and this handler is this particular class, right? So this class actually now accepts the HTTP exchange, string response, blah blah yada yada. But why am I show you why we are showing you this? Let me actually refresh here. Java and Node. Okay. And this is all the Java code. And look at the lines here to create now a server here. This is now 1, 2, 3, 4, 5, 6, 7, 8, 9. You can put this in, but again, this is just to improve readability. You have now 9 lines, not to mention Java or PHP or C++. Or you can compete with Python in readability. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11 lines here. This is huge because the less lines you have, the more readability will be your code, the more easy it will be to test, debug, improve, etc. Okay, I will create now here. Okay. Yeah, absolutely. So creating a server under this is the hard part of server Node.js. Okay, let's get into this. And let me actually create this one. Let me open up here is cursor. No, but in any case, warp. Warp here. Impurity, playwright, navigation, integration testing, playground. Okay, playwright. Playwright. Impurity. No, I'm gonna stay with that impurity. But I want to say practical algorithm, API design, functional hard parts, OOP, JavaScript XX, hard parts here. Hard parts, server, and Node.js. So I want to actually is make there, here, hard parts, server. Let me do this. No, I don't need to create that initial command here. Right. That's right. And I want to open up here. And now explore the difference here between servers. This is server code or simple HTTP server. Okay, because a simple HTTP server, exactly, simple HTTP server code comparison. Alright, .md. So that's the whole point of this. So this is on Python. This is on Python. You're gonna put it here. So this is Python. This is C++. This is C++. No, French toast way, bro. Yeah, this is Python. From 6 to here, so this is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines of code. Line of code to create a server, an HTTP server. Okay. Yeah, line of code to create an HTTP server. We have Python. 10 line of code. You have now in C. In C++. Multiple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 line of code. You gotta be kidding me. PHP, holy French toast. You have PHP here. Oh shit. One, two, three, four, five, six, seven, 4, 8, 10, 11, 12, 13, 14, 15, 15, 17, 80, 17, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right. Not to mention Java. Java in itself is, well, massive. And now this is Java. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 line of codes in comparison to C++. The hell? Then you have Node, which is very straightforward, bro. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 line of code. That's huge, bro. That's huge. That's a lot. Holy moly. Okay. All right. Then you publish those change. No, but I don't need to do this because you can say, hey, git push origin. I already add the server. No, I didn't add the server. That's bad. I didn't add the server, which is this. Now, if you want to rename that, you say git branch main. So you rename that. Then you say git remote add the origin here, and therefore git push. Say git push and make this the upstream. Okay, make this origin the place where we're going to upstream all of our change origin to this branch. That's right, we already did that. So you can actually see is the change reflected here, and there you got it. Okay, cool. And no. All right, cool. So because actually creating is a TCP server from scratch is something that requires careful. It requires a lot of things to do and to know. All right. So now we know we can create a server in this 2-line of code like this. So you create a server and then you start listening for incoming requests. Okay, so now this is how you can use the Node.js APIs. How once you know what the JavaScript does and Node works to create a HTTP server, we're using this specialized model from the net model that it allows us to create this server. So now it's like, how can we use it? So what's going on behind the scenes? So here is say, hey, what is this calling behind the scenes? All right, and as I mentioned here, it say, hey, by the time that you create now this server, it give you this objects that it was created by Node to start to use now LeafUB. And because this object contains events, methods, and properties, so behind the scene is now create is a HTTP server instance that open up this socket where you're gonna receive this data from here. Okay, and you can choose whatever socket that you have, or you can choose whatever the range of available socket that you have in that system, that it goes from 0 to 65 535 ports in your computer. Okay, but because we're using is HTTP, we use only 80. So how can we now is starting to listen for connection, because all this is just to create now the server and tells Node to create these objects, and behind the scenes LeafUB is creating. Okay, so LeafUB is this library that allows to interact with the network computer features to start listening from event. So the question is that how can we now listen for those events? And what and not only that is that how now that actually works, you know, how is that Node is capable to detect those events, especially on the net, when they happen. So what is the inner infrastructure, architecture that Node use behind the scenes? So it's starting to receive incoming requests, and this is where now the diagram from Node.js architecture comes here, because the LiveUB, the node here, have is this different queues that is going to pass over and going to evaluate any time that so it's going to evaluate this exactly. So it's going to handle this incoming request and assign to a special queue for us. So it is the input and output queue. But this is the question is how how often this happen. You know? How often the event loop is triggered in Node.js to pass through all of the phases, the timers, the timers depending callbacks, the timers depending callbacks, the prepare, the input and output, the timers depending callbacks, the input and output, the prepare, the input and output in the input and output the input and output the input and outputs, the poll or the incoming request, the poll, which is when they handle the incoming request, connections, data, etc., and the check, and then you have the check, and then the close callback. So by the time that it detects now an event that is registered in the LiveUB, it's going to pass through all of these phases. It's interesting. Okay, so it is safe to say that if, for example, it receives an incoming data from the socket network, and okay, it received an incoming data from the socket network at port 80, and it received a set timeout for both cases. It will run for both cases it will run the event loop architecture or the event loop phases. Exactly. So it detects an event. Okay, but the node process is running there. So whatever event it detects, it's gonna pass through this. It's gonna pass through this. It's gonna pass through this. So pretty much like a cashier, right? So whatever product it receives, it's gonna look at the computer, where the computer is going to scan the product, beep, and then you get it. There's another product. The cashier, we're gonna scan that, beep, is gonna do that and over and over and over. But the node process is running there. Okay. All right. Okay. Cool. So the next question is that, okay, so now that we know what's going on when we call and create a function, when we create a server in using this Node API, what's happened when we call a function in Node, right? For example, here, and this is interesting because I know that this is go beyond the scope of today's video, but here we're using is functional techniques. This is known as the point free. So in other words, is that since the shape of the function, which is the number of arguments and the shape and the kind of each one of them that this function is received and that come out of this are the same, therefore there is no need to actually pass the functions as it is. So why this is important? Because this is all entering to the realms of readability, okay? Because here we can read from these lines and we can see the relationship that's going on behind here. Hey, we create now this server that's going to handle this, do on incoming, all right? So because we are passing this as a reference here, as a point free, but we are not running this function. So we are not telling explicitly to Node, hey, I would like you to run this function. I would like you to run this set of instruction by the time that you by the time you detect that event. All right. So how is this possible? How is that Node actually call a function for us? It's because it will run that function that we pass to that model in Node when there is an event that triggers that process. So when there is an event, you're gonna pass through the event loop phases, which is the timers, okay, which is the timers, the pending callbacks, the prepare, the poll, which is where the data, what is handled, the data incoming, or the data incoming, and the network call as well. That's what we have here. The poll incoming data and connections, and then the check to see that everything is good to move on to close callbacks. All right. So it's going to evaluate this. It's going to, anytime you take an event, it's going to evaluate this phases. And if one of those phases are actually has something, then it's going to now trigger that. So that's quite interesting. So because at the end of the day, JavaScript is just a single thread language. It's run synchronously. Okay, what we're doing behind the scenes, where we're passing a functions like this, okay, is that, hey, I want you to Node to create these objects, and by the time that the events happens, using the leave-UB, I want you to now run these functions and then inject this parameter here. So this is two stuff that's going on here, especially when you are calling methods in Node. All right. So when you're passing a set of instructions to any of these Node models, that is, hey, I want you to run this function. Okay, automatically run this function and inject the arguments that this function must receive, which is incoming data and the functions as going out of that data. Makes sense. Makes a lot of sense. Makes a lot of sense. Okay. Incoming data and function to set outgoing data. So because this is now objects that are auto insert by Node by the time that it receives an incoming stream, incoming message from the sockets, it's going to parse that because it comes into a raw octet stream. It's going to parse that. It's going to auto run that functions and inject these parameters for us, the request, which is known as the request and response object. But this is now is the incoming data, all right, that has this, for example, the URL and the headers, and the other it also contains the body, as well as the set of functions to talk to the Node.js, aka the leave-UB, that allows us to now send that message back to the client. This is interesting because it's now Node where passing is this function is going to do a lot of heavy and tedious work for us, which is it's going to parse this octet stream for us and then auto run these functions by injecting this argument. In other words, injecting is the incoming data and the set of functions that you can have access to the networking servers, especially to the HTTP server, that is going to communicate to through Node.js, leave-UB, hey, I want you to now is send this message back to the client. Holy moly, bro. That is mind-blowing. Calling a function under the hood. Calling a function under the hood. All right, Jesus.
Node inserts two.
Okay. So let's go to now look at this, right? The creating the server under the hood, and then
Two arguments automatically. One is going to be, well, let's see it. Let's just see it. Here we go. Here it is. Let's have Sarah Rose's message come in. Here comes Sarah Rose's message. Here it comes in. She's asking for what tweets?
Node.
The Node tweets. Great long business reading now. Here comes the Node. Here she comes.
Graylon.
How has formatted that message? The Node tweets. Great long business reading now.
Great long distance reading there.
In come the node. Here she comes. We'll learn more about how that's formatted that message, so we can really investigate it. But now, let's just know this. In comes the message. It's arrived. In Node. But problem. Big problem. This message is formatted in a way that I definitely do not want to have to deal with in JavaScript. It's a string of characters. There is an HTTP message. I can actually get access directly. If I instead set up my open channel using the net built-in label, then the data that will come in, I'll actually get it back in here in just a pure
string as
the actual message itself.
an octet string.
If I set up this background feature, well, before we see that, just a second, before we see that, in comes the message. What do we want to have happen at that moment? Zep, before we talk about any inputs, what do we want to have run at that moment, Zep?
The dual incoming function.
Take it up here, and it's going to, look at this people, it's going to come into JavaScript, and so I'm going to do everything that Node's going to auto do with the purple pen. So, Charlie, what will Node pen? The Node pen, the automatic, not done by us pen, we're going to have happen in JavaScript. Execute code to Charlie, losing your job. Put parentheses on the end and execute that function. So we're going to see this again and again and again. This is all that Node does. So we're going to see this again. We'll get very, very used to this model. But this function is auto-running. Purple means it's going to have in comes a message and it's going to auto-run this function. It's going to, what does it mean? What does that mean? Grab that code, throw it into JavaScript, and start running it. And there it is. And what we want is
And pass through that through the call stack.
back to Node.
Pass that through the call stack.
Response message, another HTTP message, back to Sarah Rose's man. How are we going to do that? We better have inside this function's code access to this inbound message, and somehow access to this message going back, so we can add stuff to it, data, tweets, HTML, CSS, send back. Do I get these two strings of characters directly available to me in here? I actually don't, because Node wants to make my life easier. So instead, and this is the other big part, so we'll see this again and again, don't worry. Instead, the next thing it does down here in Node, as soon as it has changed it, it's immediately going to send an HTTP message ready to send back, by the way. But they're in a format we don't deal with in JavaScript. JavaScript not great at parsing text, that part of text. But we'd rather deal with it. At parsing, P-A-R, parsing text. No, it's not. We're not going to do that. So instead, Node is going to automatically package up to JavaScript objects. I'm going to do them in. I'm going to do them purple because they're being set up by Node. So they're JavaScript objects. It's going to auto-create them. Number one and number two. We're not going to give. They're not going to get names by Node. Which is going to be weird. How do you access them? Shall I have you know how to access them? Get names. What word would it be?
Parameter.
Alright, so it's going to Child is going to auto-create number one and number two. We're not going to.
It's going to create this parameter, but it's going to pass the arguments to this function.
Alright, so it's going to automatically create. When the inbound message from Sarah Rose arrives, it's going to immediately automatically create two objects. And these are the objects. So if you make it like, oh, I don't have to build my nice pretty app. But if we understand these two objects, we have everything we need for successful Node development. Now I started off by telling you that Samir Buddha guide, that the Node authority, all the advantages, but we look for Node beyond the basics. And a list of 27 questions, interview questions, if you are asked in the senior interview, you need to only answer to get senior coach. We're going to answer them, and already, by the way, actually, but many of them already, because this is what's going on. Two auto-created objects. The first one is going to package up for us in a nice JavaScript object format. We love JavaScript objects. It's pretty easy to access, get stuff out of. So to package up the important information from the inbound message. What's the most important information we've got from the inbound message, Michael? There's no body here. We'll see that later on. What the URL. And it's going to give us a little property on this object called URL, which is a string of, well, not the name, just the path, which is the next bit here, the specific bit, it's /load. Because that's what Sarah Rose wants. She wants to know. And it's going to Node, we'll end to show you the Node's doing this, it's going to look into that HTTP text message, it's a string of text, and grab out the URL. It's going to parse it, and grab out the URL and stick it in this object. And that object is going to be inserted magic automatically into this execution context. It was automatically created by Node automatically putting parent on the end of the function that we pass to it during incoming to say when you get an inbound message, auto run during incoming. And there's two parts to auto running the function. One is running its code, and the other, raise your hand if you know, Virginia, inserting out, which is as good as saving data. That's what it is. It's inserting data to make it available in here and saving it in here. Yeah, it's not a very thing to say, but so that wasn't wrong, but it's specifically, that was wrong, but specifically it's inserting arguments. Okay, here they come. First one is that first object. All the data we need, let's stick it in, it's in the local memory. It comes in, though, people, without a label. So how the hell are we going to access the property of an object that has a label? Michael? Which we do. We give it a placeholder. We know. When we say the dual incoming function, we know that when it gets run, it will have automatically, by node, inserted two objects. And so we give it two placeholder names that those objects will be accessible by. And we can call them whatever we want. As long as when we then try and refer to them inside the function, they have referred to them with the right label. And so what do we give, Michael, what do we give the object that's going to auto insert the first one, all the data? What do we give it? What do I give it?
Incoming data.
Incoming data. I don't call it request. We'll see, that's what we always use the term general, rec or request, but I don't want you thinking that's like a keyword. It's not, whatever we want to call it. Okay, there it is, incoming data. And what gets inserted? This whole object with a whole bunch of properties, by the way. I just put in only the URL, but it's a whole bunch of properties added on. Headers, not body. Yeah, body is captured in an interesting way, which we might see later on. But all that data on there. Okay, I've got all the data. But now, I didn't bring all that data in from Sarah Rose's request to not send some data back. My little message here that shows it's ready to go back. Oh, it's sitting there. It's sitting there ready to send back. Node made it for me behind the scenes. It's sitting there. Oh, I want to go back. How the hell do I get access to it? Well, wouldn't it be nice, people, if the second object maybe had a property on it called, I don't know, maybe data, something like that, which we could then, that object would go in here, and then we could access, add value to it, send back. It's not how it does it. Instead, here's what it gives us. It does give us an auto-created object, automatically created by node, that yes, is inserted in here as the second input, but that object does not have a property on it that we can add data to that then gets sent back. Instead, that object has a bunch, a ton, but we're just going to use one for now, of functions, methods, including one called end, JavaScript functions, labels, for when we run this function, this object will be thrown back into JavaScript, we're then going to grab the end function, run it, and whatever we pass to it as input will be used to add data to this response message. This object has all the data and we can grab it directly. This object has functions that when run from JavaScript will be labeled to update the data on the message that gets sent back. Fundamentally different behaving objects. One has actually got the data on it we can access. The other has functions that when we run them from JavaScript will be labels back into Node that adds stuff to this message to send back to Sarah. Let's see in action. In comes the second auto-created object. In it comes. And this one gets what parameter name? Rich, what's the parameter name for the second inserted object? Fantastic. Functions to set outgoing data. Is this a keyword, Rich? No, it's just whatever. It's just because they came in. The auto-created objects are anonymous. They've got no name. So we better have given them a placeholder. In comes the object. It has on it a whole bunch of functions, but one of them is end. And I think, I have a feeling, we're going to use that function. Oh, look at that. What are we going to look for? Set which object or which parameter name are we going to look at? Which object, which one is the function to set outgoing data object, and then we're going to look at what function on it. The end function, and that's it. Exactly what we're going to run. Functions to set outgoing data dot end, whatever we pass to it, which is here, welcome to Twitter, welcome. This function dot end, when run, has an intimate connection back to Node. It's a Node function, and it's going to node down to this HTTP message where it's going to add welcome to the message, and then that message is going to be sent back to Sarah Rose's Mac. So we have in 1, 2, 3 lines of JavaScript built an entire server. Because in JavaScript, all the black stuff's JavaScript. There's not many words done in black. All the purple stuff is built in node features. And now, look at that. It has a function that's going to auto-run. It has auto-insert data arguments. It has auto-inserted arguments that it automatically made, and it threw into the function that's auto-run. So that we had access to the incoming data from the incoming message, and access to the outgoing message to add data to it, the tweets, or in this case a very boring message on Twitter, via object that gets passed in a bunch of functions. When run, we are executing the end function, executing it, doing it. It's going to give us back access to this message again. But this is the absolute essence. I'm going to see again and again and again. There is nothing else in this language. Whenever we use a background computer internal feature, it could be the file system, it could be the open network socket, it could be other features of the computer itself. Every time we go to use a built-in label that sets up a Node C++ feature that has access to the background feature, we're going to need to add a function that Node will auto-run. Whenever the background feature gets activity, or we get a file, or the file gets
Whenever
out of the file system,
gets activity here.
auto-run, we're then going to need to design that function such that it's ready to receive incoming data, ready to receive the auto-created and auto-inserted data that's relevant in this case is the input data, Sarah Rose's Max request data, and a bunch of functions in this case that allow us to access again with specific responses to some back servers. We're going to do this again and again and again. Let's start with who's the first person? Andrew. Let's start with you, Andrew.
I'm not sure so mega ones, are they applied as in slides, or is this an intentional something special?
No, oh damn, my friend Martin got to put the semicolons back on. Andrew, rescind that question. Everybody online, semicolons matter, and actually, particularly in Node, they do matter. They do matter because if you miss them off, JavaScript strings can string your code together and lead to errors that can be quite hard to find. Ignore this very bad practice. Semicolons, bad copying and pasting into this presentation from the code editor. Thank you to Andrew. Actually, a very helpful thing for everyone. Who's the first person? Andrew, let's start with you, Andrew.
I'm not sure so mega ones, are they applied as in slides, or is this an intentional something special?
No, oh damn, my friend Martin got to put the semicolons back on. Andrew, rescind that question. Everybody online, semicolons matter, and actually, particularly in Node, they do matter. They do matter because if you miss them off, JavaScript strings can string your code together and lead to errors that can be quite hard to find. Ignore this very bad practice. Semicolons, bad copying and pasting into this presentation from the code editor. Thank you to Andrew. Actually, a very helpful thing for everyone. Go ahead. Please ask me more about my value of JavaScript.
I feel like I see references and errors.
Let's see how we handle errors in just a few slides. No problem. Great question. See you there. Which one? John.
Yeah, just to be clear, the only code that no one will ever have access to is provided in the
Yeah, that's a good way of putting it. The only function code that never auto-run. Well, on the same note as Sarah Rose's question, we actually are going to see that if that request comes in very happily and successfully, cheerfully, great request, no errors, and we repeat, that's going to flash a message out here saying, request. But we can see that if another situation, an error, maybe the client sends a corrupted request, it might not flash request now, and therefore it might not end up triggering something else. So you're going to get more control than you think. Mohammed, go next. It's a weird one, right? We can set the label. I could call it, what I could call it? Mohammed's auto-created object function. No, not Mohammed's. Mohammed's favorite node auto-created set of functions. And as long as you then refer to it by the same label, when we want to access stuff on it, all we try to access on it, or something like that. Sorry, Mohammed. Which is what name?
No.
No docs. It is literally got. That's why we spend most of our time. As long as you have this internal mental model, that's the point of. That is the point. As long as you have this under the hood mental model, you just go to no docs and you go and look. Once you want to.
We can sometimes use exports, and other times we have to use model export.
And therefore, how do I need to structure the function that I pass as the auto-triggered by node function, such that I know what kind of design to run. And then the auto object.
What is the call sign?
I'm just going to access it.
Let me give you a taste of kind of question you will be able to answer after reading this book. Look at this as your no knowledge. If you can answer most of the question, this book is probably not for you. What is the relation between the node and V8? Can Node work without V8?
Yeah, it's a simple.
No, because it depends on V8.
You finish editing the message.
Why it depends on V8? To parse JavaScript instruction.
We set other bits of information. We can set the headers. We can set the body. We usually run end off with nothing in it, as in only John can say, "Hey Node, I finished editing stuff for this message."
I say no. I say no. But after all, this is just a label that are if Node are just labels that are exposed to JavaScript, it means that yes, you can do that because it can work with any JavaScript engine. Through V8 is the default and most commonly used engine, the alternative implementation of Node, because after all, Node is the bindings. Because Node.js is the bindings from JavaScript to the computer's internal features.
And most people will say, because what is this? So we typically wouldn't use anything for this, but it gives a very, very lightweight way of setting data on the question?
Yeah, so just a curiosity, what happened if we append .listen to the create server doing incoming?
No problem. And most people do that. Most people will say, because what is this? So this returns an object, which has got a bunch of functions on it.
What is a call stack? It is part of the V8. Since V8 is the JavaScript engine,
Java is an evaluated language.
yes.
This here, when it returns out the object, it actually gets rid of that
Yes.
and turns it into
So the call stack is the data structure that keeps tracks where we're currently at the code. Alright, it's a data structure. Sorry, it's a data structure that are telling you what is which line of the code we are, and is part of the V8. Yes.
Right? You not doing it just because you think they're like JavaScript is single threaded, so it has to do different structures.
No, it's not that. I'm doing it for clarity to show you that
What is the event loop? Is part of the V8? No. It's part of the host environment.
this background feature, file on the server, which
It's not part of the V8. It's an important architectural distinction because the event loop is implemented by LibUV. And this event loops is the event loop that handles the event loops. What is the difference between set immediate and process next tick?
it defaults to 80.
What are the major difference between spawn, exec, and fork? How the cluster model works? How is it different? How it is different than using load balancers? What will Node do when both the call stack and the event loop queue are empty? What are V8 objects and function templates? What is LibUV and how does Node.js use it?
Which doesn't default to entering 80.
I know what it is. What are the V objects and function templates? What will Node do when both the call stack and the event loops are queue are empty? What will Node do when both the call stack and the event loops queue are empty? It will continue to run the process.
Inserted function back in the job to execute in our main thread, in our thread, in our single thread from outside of Java.
If nothing is pending,
Where is that function allowed back in? What if there's 30 people who want to go back at the same time?
if there are timer scheduled in the future, Node will wait until the nearest time expires. Mhm.
of exactly when any auto-run function of code is allowed to auto-run back in JavaScript. Any function or
Mhm. Mm. Mhm. Buenas. Imagínense que quieren hacer pastel de papa. Bueno, vamos a escribir por acá pastel de papa. Pero no saben todos los ingredientes que llevan. Bueno, con Tote pueden cliquear ese botón del medio de ahí y les va a desglosar todos los ingredientes que necesitan. Además, pueden agregar más y obvio todo lo que quieran. Además de esto, tenemos una feature que es la feature principal, que es el One Click Checkout. Con el One Click Checkout pueden ir a cualquier lista que tengan dentro de Tote, apretar este botón de acá, elegir uno de los supermercados más grandes de la Argentina y con un clic, ingresando su número de teléfono por acá y van a tener que esperar un poquito que les llegue un código de confirmación, en este caso es data moqueada, pero cuando les llegue el código de confirmación van a ingresarlo por acá, continuar y se va a empezar a procesar la lista de compras generando un carrito de compras listo para procesarse en el supermercado que hayan elegido, ¿vale? Portales más.
Tote surge porque tanto Tade como yo vivimos solos y siempre tenemos este problema de ir al supermercado, olvidarnos cosas o simplemente no saber qué comprar, ya sea para comer o cualquier compra que se pueda hacer en el super. Y
landing on immediately began searching into the crowd.
La misma vaina que las negras en Estados Unidos, ¿me entiendes? Por eso yo cuando vi esa vaina así que I recognize this S. Reconozco esta vaina, manín. Y yo dije,
Te estoy
no.
diciendo que regresamos de nuevo a nuestro país y se siente regresar. Mira acá, a tu tierra natal. ¿Mi tierra natal, seguro? Claro. Chamo, qué hermoso es mi país, pana. Chamo, yo sabía, pana, mi país es bello, pana. Mira, mi país es lo máximo, lo mejor.
Malvada se llamaré.
Inclusive un par por 35, 2 por estos lugares. Por 60 o 3 por 80.000 pesos, de 35 al 45 puedes combinar talle, modelo y color totalmente elección. Envíos a todo lo que es Cabo y Gran Buenos Aires en el día y pagas al recibir. No dudes en consultarnos que te pasamos toda la info. Estos lugares modernos, encima con el QR que no sé ni cómo mierda se usa. Lo único que espero es que el café sea decente. Ponle un poquito de onda, güey. Bueno, acá estamos, chicos. Flat white con arte latte para el caballero, un cinnamon roll de Liz Exquise, el caramel macchiato y la cheesecake de Bloody Bean de nuestro maestro pastelero. Todo hecho con mucho amor, les va a encantar. Que lo disfruten, chiquis. ¿Qué haces? Pará, tenemos que sacar una foto, güey. Foto, la puta, te parió. Déjame tomar el café. Todo querés grabar. ¿Y esto qué es? ¿Arena para el hámster?
Arena para el hámster,
El
marico.
café está frío. ¿Esta media luna qué? Es un cinnamon roll, señor. A mí me chupa un huevo si son un cine de Monroe. A mí traeme una media luna, papá, dejate de joder. Esto es un compacto de masa, hermano. No, es un cinnamon roll, es algo muy tradicional. Y el café frío también es muy tradicional. Es la temperatura del barista. Normalmente el flat white se texturiza con la leche con menos aire. Entonces este café se aclimata entre los 55 y los 62. Déjame echar las pelotas, tráeme un café normal, boludo, dejate joder. Para, bueno, esto es parte de la experiencia. Experiencia las pelotas. Si no me traes la media luna en 2 minutos, me voy. Y vos, mozo, decile al que hace el café que aprenda a hacerlo caliente. Para caliente ya está vos, abuelo. Encima que nos van a romper el orto, me traes a tomar estos cafés para especiales. Estos cafés de especialidad, quédate tranquilo, lo voy a invitar yo. Señor, acá está su media luna, ¿eh? No, flaco. ¿Estás bien? Te quería hacerle un chiste al señor para que se relaje. Por eso le dicen café para especial.
Epa, chamo, burde rata, vale. Mamá huevo. Mamá huevo eres tú, vale. Pendiente con una vaina, ¿me estás escuchando? Naguara, chamo. Marico. Epa, vale. Senda bruja es lo que eres tú.
Tú le das configuración. ¿Qué sigue después que tú le das configuración? No llores, que tú no vas a arreglar nada llorando. Hasta que tú no me pongas a mí el fondo de Chayán. Vamos.
¡Ay, marico, no! No llores, no me llores. No, basta. Hell no. A lot of distraction, which is good, fantastic, absolutely. No thanks. Good, man. Nombre que figura en la tarjeta. Bullshit. Oh, that'll be all for this video. Take care. Bye bye.